Example 1. A mechanic must estimate the total time for a particular servicing. She figures 0.4 hour for an oil change, 1.5 hours for a tune-up, 0.6 hour for a brake check, and 1.3 hours for air conditioning service. What is the total number of hours of her estimate? So this is telling us we're going to need to add. And when we add decimals, all we have to do is line up the decimal points. That's getting a common denominator. Like when we have fractions and we have to get a common denominator, well, lining up decimal points is getting the common denominator. So I'm going to take these four amounts, 0.4, 1.5, 0.6, and 1.3, and I'm going to add those together. So I'm going to add 4 plus 5 is 9, plus 6 is 15, plus 3 is 18. So I'm going to put down my 8 and carry my 1. Now the decimal point just comes straight down. So I put a decimal point there, and then I add 1. 1 and 1 is 3.8. So the total number of hours of her estimate is 3.8 hours. Example number 2. The following are diameters of some common household wires. Number 10 is 0.102 inches. Number 11, 0.09 inches. Number 12, 0.081 inches. Number 14, 0.064 inches, and number 16 is 0.051. Now, it's important to point out that the number of the wire is not a number that we will need to do anything with. Those are just descriptive numbers. So sometimes you'll have these extra numbers within a problem that are descriptive and they don't get added or subtracted or multiplied or anything like that. So they ask us in part A, the diameter of number 14 wire is how much smaller than the diameter of number 10. So this is telling us that we need to subtract. So for part A, we need to take the number 10, 0.102, and the number 14, 0.064, and we need to subtract those. And once again, we make sure our decimal points are lined up. We're going to have to borrow here. So I'm going to borrow from the 10 and make it a 9 and make that 2 a 12. So 12 minus 4 is 8. 9 minus 6 is 3, and then I'm going to have a 0, and then I'm going to drop my decimal point. So the diameter of the number 14 wire is 0.038 of an inch smaller than the diameter of the number 10 wire. Now in part B, they say the number 11 wire is blank than the number 12. So we've got to compare number 11. So number 11, 0.090, and number 12, 0.081. So the larger one is the 0.90. Now even if they had left that decimal off, because we don't have to have the 0 at the end, it's still larger because we would have to get a common denominator. The way we get a common denominator with decimals is just make sure they have the same number of decimal places after the decimal point. So 90 is bigger than 81, so number 11 is larger than number 12. And the difference, again, this word difference is what tells us we need to subtract. So the difference is, if we subtract these, again, I'm going to have to borrow from the 9 and make it an 8. This becomes a 10 minus 1 is a 9. 8 minus 8 is 0. I need to bring down another 0. So 0.009. So the difference is 0.009. Now this is technically not required. And if there was a 0 on the end, like this one, it's also not required. But it's a better format in both cases to have those zeros there. Part C. John measured the thickness of a wire with a micrometer as 0.076 inches. Assuming that the manufacturer was slightly off, what wire size did John have? So we're looking for the number of our numbers that is closest to 0.076. So we've got a 0.102, we've got a 0.090, we got a 0.081, a 0.064, and a 0.051. So which one is closest? Well, it's definitely not going to be the 0.102. So let's subtract these and see which one is closest. I'm going to start with the 0.051. That one is 0.025 off. Okay. 0.064, 0.076 minus 0.064. That one is 0 or 0.012 off. Okay. 0.076 minus 0.081. That one is only 0.005 off. That means this one's going to be off by more. And 0.076 minus 0.090 is off by 0.014. And then I'll just go ahead and do the other one, the minus 0.102, just to show you that that's 0.026. So the one that is the closest is this one, the 0.081 wire, so that's number 12. So number 12 was only off by just a little bit, and that's the closest to the one that he actually received. Example 3. A certain machine part is 2.345 inches thick. What is its thickness after 0.058 is ground off? So this is telling us we're taking off, taking away. We're going to subtract. 2.345, 0.058. We're going to line up our decimal points. Going to have to borrow here. I'm going to borrow, since 4 is not enough, I'll just borrow from 34 and make it a 33. And that's going to give me a 15 minus 8 is a 7. And then 33 minus 5 is 0.28. And then bring down the 2, because remember there's a 0 here. So the final thickness is 2.287 inches thick. Example number 4. A piston must fit in a bore with a diameter of 3.3790 inches. What must be the diameter of the piston given the clearance shown in the diagram? So they're asking us to find this inner diameter here. Okay, we know the total all the way across, and we know these two sides. So in order to find this, we're going to need to subtract 3.3790, and we're going to have to subtract the 0.0045 2 times. So I'm going to go ahead and add those together, 0.0090, because 5 and 5 is 10, 0 carry my 1 is a 9. So I'm going to subtract 0.0090. So I get a 0 and a 0. 0.73, 3.37. So if this is exactly 3.37 inches, it should fit into that bore. So that's 3.37 inches. Example number 5. What is the combined thickness of the following 5 shims? Well, combined, that's telling us we're going to need to add. And so notice they all have 3 places after the decimal, so we just line those up, and then we'll add. And of course, you can use your calculator on all of these, but I do them manually just so you see how it's done and that it can be done. So 0.008, 0.115, 0.121, 0.187, and 0.005. So I'm going to add 5 and 8, 13, 1 is 14, 7 is 21, 5 is 26. So 6, so it's 6, carry my 2. Then I have 2 plus 0 is 2. 1 more makes 3, plus 2 is 5, plus 8 is 13, so it's 3, carry the 1. Then it becomes 1 and 0 is 1, plus 1 is 2, plus 1 is 3, plus 1 is 4. So that's going to be a 4. And my decimal point comes straight down. And notice I didn't write the 0 in front. It's not required, but it is better format to do that. So 0.436 inches is the total thickness of the 5 shims stacked on top of each other.